Lesson 11.3. We are continuing to talk about probability. Okay, so yesterday we kind of introduced probability. We did the more basic probability. Today we are looking at probability options where they will either use the word and or. So we'll be combining some probabilities. You will want to pay careful attention to the word and versus the word or, because it will tell you a lot about how to work that probability problem. Now, a little bit of vocabulary. Independent versus dependent events, which if you have a basic idea of the difference between independent and dependent, it's the same thing. Okay? If two events are dependent events, the occurrence of the one event affects how the second event can occur. And this matters in probability. Okay? If what you do the first time affects the second time, they are dependent events if one affects the other. Independent events, the occurrence of two events are independent of each other. So if what you do the first time has nothing to do with the second time, they're independent events. Okay, so just understand the difference between dependent and independent. Couple examples here to make sure we understand. Is each pair of events dependent or independent? So if I roll a number cube and then spin a spinner, are those dependent on each other or are they independent?
Independent.
Does what I roll in that number cube, does that affect what I'm going to get when I spin the spinner?
No.
No, they have nothing to do with each other, do they? So these are an example of independent events. I'm just going to write independent. If you need a little bit more than that, it's because rolling the number cube and spinning it, then spinning a spinner, they don't affect each other. That's the idea of independent events. B, picking one flashcard and then another from a stack of 30 flashcards. Independent or dependent events here? So I pick one flashcard and then I pick a second flashcard from the same pile.
Dependent.
So because they are from the same pile, does it make sense if we say dependent? Because if I pick that first flashcard, am I drawing from, do I have exactly the same choices the second time around? No, I have less choices. No, I have one less choice. And so this is an example of dependent. Okay. Now, it would be different if they indicated something between there. But the fact that you pick one doesn't say put it back or anything. And then pick a second. The first probability affects the second probability. And C, select a coin from your pocket, replace the coin, and select again. Independent. Am I selecting from the same coins both times?
Yes.
Yeah. I pick a coin, but here's the catch. Did you see it? You replace it then. So now I'm back to the same original grouping, and I select another coin. So these events are independent of each other. Okay. Feel free to write some explanations down there if you feel like you're going to need some explanations when you look back to help yourself, but are we okay with those basic definitions?
Yes.
Again, today I worked through the homework to make sure I knew what you needed to know to do the homework, and you have some that are just pick, is it independent or dependent? So, okay, moving on then. Example 2. With this example, we are talking about how we find the probability of A and B. So if A and B are independent, how we find the probability of A and B. And you'll notice, what are we doing with the probability of A and B? We are multiplying. So when you see that word and, you do want to think multiplication. Okay, so when you see the word and, think multiplication. And we're going to use this example for example 2. At a picnic, there are 10 diet drinks and 5 regular drinks. There are also 8 bags of fat-free chips and 12 bags of regular chips. If you grab a drink and a bag of chips without looking, what is the probability that you get a diet drink and fat-free chips? So did you notice that word? And. It was a diet drink and fat-free chips. So we're looking, if I write this out, what you're going to see. Diet drink and fat-free chips. So I'm shorthand yet, but if I say, okay, the probability of diet and fat-free. Well, first of all, we need to find the probability of a diet drink. What's the probability of picking a diet drink?
2/3.
Thoughts? Huh? Okay. Okay. So if you're questioning Doug's 2/3, what about Delaney's 10/15? Is that better?
Same.
Okay. So diet drinks, there's how many diet drinks? 10 out of how many total drinks? 15. So I would go 10 out of 15 to get started. If you go ahead and convert it to a decimal right now, I would warn you, don't round. Okay, because if you round too soon, it will get you in trouble later. Just saying. Now, it uses the word and. What did I say we're going to do for and? We're going to multiply. And then we want to know the probability of fat-free chips. What are your thoughts on fat-free chips?
Gross.
Okay, let me rephrase that. What are your thoughts on the probability of getting a bag of fat-free chips?
2/5.
Okay, Levi says 2/5. Hogan's like, I like 8 out of 20 better. Are they the same? There's how many fat-free chips? 8. Out of how many bags of chips? 20. Now, to be honest, I am going to reduce this. I wrote down the 10 15ths and 8 20s because I know that I want you guys to see the beginning. But 10 15ths reduces to 10 and 15 both divide by 5, and so it does reduce to 2/3. 8 and 20 both divide by 4, and so 8 and 20 reduce to 2/5. How do we multiply 2/3 times 2/5? You just multiply across, yes? 2 times 2 over 3 times 5. 4/15. I personally prefer this answer. Math Excel, again, though, wants lots of decimals. I won't say all decimals, because I missed, when working through it this morning, I missed one because I put a decimal in, because all the others had been decimals, and then they wanted a fraction towards the end. So, read your directions. What is this as a decimal to 3 decimal places?
0.26 repeat.
Okay, so if I do 4 divided by 15, it's 0.26666.
Yeah.
So that 6 is going to tell the 6 to go up to 7. So in my opinion, 4/15 or 0.267 are good answers. Math Excel is more likely going to want 0.267. I'll be honest, I haven't thought about what I'm doing come test time, because I kind of like the fractions better, but you're so getting used to these decimals now, so we'll see. Questions there? Got it one way or another? Okay, let's look at the other one real quick. What's the probability you get a regular drink and regular chips? So this time I'm doing the probability of regular and regular. I'm shorthanding. What is the probability of regular drink?
1/3.
Okay. And what did that 1/3 start off as?
5 different.
5 regular drinks out of 15 total drinks. What's and tell me I'm going to do? We're going to multiply. What about a regular bag of chips?
3/5.
And what does that 3/5 start off as? 12 regular out of 20 total. Okay. So 5/15, divide 5 and 15 by 5, and it is 1/3. 12/20, 12/20ths, divide them both by 4, and we are at 3/5. Before I multiply 1/3 times 3/5, I'm going to do something. I personally am going to cancel my 3's. I keep showing it, even though I know a lot of you don't like it. 3 divided by 3, they're both 1's, and so 1 times 1 over 1 times 5, 1/5. What is 1/5 as a decimal? 0.2. Okay. Are we okay with the idea of independent events?
Yes.
I will warn you, it came to my mind just now during this class while teaching this. There might have been one where you have to do dependent events. Which the difference that I have to warn you of, and we talked about in class the other day, is that if it's dependent, that would be like picking a diet drink, not putting back that diet drink, and picking another diet drink. So just realize there's one less diet drink and one less drink to pick from, and so your second fraction numbers go down by 1 each, okay? So just kind of be aware. We may have to talk about that tomorrow because that might be in homework and it's not in the notes, so. Okay, moving along if you guys are good with this. Bottom of that front page, we get to talk about mutually exclusive events. And mutually exclusive events are 2 events that cannot happen at the same time. If 2 things are mutually exclusive, they cannot happen at the same time. So, and it does mention if A and B are mutually exclusive, then the probability of A and B is 0. That would be A and B happening at the same time. That is 0. Now, so we're first going to talk about just how to decide mutually exclusive versus not mutually exclusive. So in this section, you roll a standard number cube. Are the following events mutually exclusive? First of all, let me ask, what are my options when I roll a standard number cube? Okay, that's old news, right? So rolling a standard number cube, 1, 2, 3, 4, 5, 6. Okay. So is it possible to roll a 2 and a 3?
And at the same time.
At the same time.
No.
Okay, so this is rolling a standard number cube once. Can you roll a standard number cube? So can we roll a die and get a 2 and a 3 at the same time? No. So what does that mean?
Yes.
These cannot happen at the same time, so they are mutually exclusive. Okay, and if you want a side note, mutually exclusive cannot happen at the same time. Okay. B, rolling an even number and a multiple of 3.
Yes. Can happen.
Okay. What are my even numbers?
2, 4, 6.
In this situation, 2, 4, 6. What about multiple of 3? What do we mean multiple of 3?
6.
And
3.
3. Officially, multiples of 3 start at 3 and count by 3s, right? 3, 6, 9, 12. The only ones that matter here, though, are going to be 3 and 6. So here's the deal. Can I roll an even number and a multiple of 3 at the same time?
Yes.
Yes, because I could roll a 6, and a 6 satisfies both pieces. So is this mutually exclusive or not mutually exclusive?
No.
Okay, this is not mutually exclusive. Okay. I will say I've taught out of some books that the options are mutually exclusive or the opposite of mutually exclusive is inclusive, but they just use not mutually exclusive or not mutually exclusive here, which I don't care for, but. Okay. Rolling an even number and a prime number.
It's possible too. Good.
Okay. So, what are my even numbers? 2, 4, 6. Okay, let's review. Some of us need it, I know. What does it mean to be a prime number?
Nothing can be multiplied to itself.
Okay, so official definition, a prime number has exactly 2 factors, 1 and itself. So you guys are saying it can only be divided by 1 and itself. That's exactly correct. But it has exactly 2 factors, 1 and itself. What numbers are prime numbers between 1 and 6?
1, 2, 3, 5.
I'll take part of those. 3 and 5 are the obvious primes because they are 1 times 3 and 1 times 5, and they're odd numbers, so that's what we think of. 2, it's even, but it's prime, isn't it? It's the only even prime number, 1 times 2. Doug wanted me to write 1. Why did I write 1? Okay, 1 times 1 is 1. How many factors is that? That is 1 factor. 1 is a weird number, and it's a unique number in that it's neither prime nor composite. The opposite of prime is composite. Prime is exactly 2 factors. Composite is more than 2 factors. Prime or 1 is neither of those. So, now, back to the question at hand. Can I roll an even number and a prime number?
Yes, do.
So this can happen at the same time. So this is another not mutually exclusive.
The last episode of Moon.
What?
The last episode of Moon Knight comes out today. Sorry.
I thought it was something important.
No, not at all.
Okay. Last example in this section. Rolling an even number and rolling a number less than 2. Can those happen at the same time? No. What are my even numbers? Again, 2, 4, 6. What are my numbers less than 2?
0.
On a die, how about we just talk about 1? Okay? On a standard number cube, excuse me. Any overlapping? No. So these cannot happen at the same time, so they are what type of events? Mutually exclusive. Okay. We're going to practice with some mutually exclusive events on the backside. And I already mentioned, I said you need to know what's what here. And when it says probability of A or B, so when you see that word or, realize we're going to talk about addition. And you're going to think multiplication. Or we're going to think addition. Now, I'm going to start with the bottom example. If A and B are mutually exclusive, okay, if they cannot happen at the same time, we're just going to add the two probabilities. If they can happen at the same time, we're still going to add the two probabilities, but then we're going to subtract off any overlap. That's the easiest way for me to put it. I will show you examples, okay? I'm not going to leave you hanging there. Now, let's look at these top sections. This is finding probability for mutually exclusive events. Which, mutually exclusive, they can't happen at the same time. We're just going to add them. At your high school, a student can take one foreign language each term. 37% take Spanish, 15% take French. What is the probability that a student chosen at random is taking Spanish or French? So I want the probability of Spanish or French. Now, and the key is these don't overlap because a student can take one foreign language each term. Does it say you can take Spanish and French at the same time? No. You're taking one or the other. So, start off with, what is the probability of a student taking Spanish? That is what?
37%.
Given is 37%. Or, because I see the word or, I know I'm going to add. What is the probability of a student taking French?
15%.
15%. Don't make this difficult, folks. It's not. They are mutually exclusive events. We are adding them. What is 37% plus 15%? 52%. Because they gave us percents, we're going to leave them as percents. I think you have a couple similar in the homework where they give you percents. Use percents. In the same situation, about 9% of the students take Mandarin Chinese. What is the probability that a student chosen at random is taking Spanish, French, or Mandarin Chinese? So probability of Spanish, French, or Mandarin Chinese. What are we going to do here?
Did you use the probability from the last problem instead of having to redo it?
Yeah, you could use it. If we use the probability from last time, that was Spanish or French. And then so we would take the 52 and
Add 9.
add the 9 on. Okay? Or it's just re-adding. Spanish was 37 plus French is 15 plus Mandarin Chinese is 9. So whether you do 37 plus 15 plus 9 or 52 plus 9, we get 61%.
They must have a lot of languages.
They're probably up there.
It's a good to
I think
the last one being
I went to Kokomo and I think I had 4 choices. So
That would be a lot of people taking Russian. Or German. Those are usually the other 2 languages.
mine was Spanish, French, German, or I think Latin was our other one. I know, not a normal one, but I think Latin was the other one. So, okay. Now, before we get started on this bottom section, first of all, I was color coding this morning to help out a little bit. Right here, guys, there's a big old typo I have to point out. If you notice over in the key,
Orange.
it's orange, red, orange, yellow. Orange is not used 2 different times. This second orange should really be a green. Okay? That way we have something when it asks us about green. Now, Green, guys, is just, it's not shaded in. So orange is anything shaded in full. Red are the diagonal lines going up to the right. Green is just not shaded in figures. And yellow are diagonal lines going up to the left.
There's only one.
Yes, there's only one. It's only that triangle that has lines going up to the left. So I went this morning and outlined them just to kind of, you know, help up here. Okay. So, as we look at this, suppose you reach into the dish and select a token at random. What is the probability that the token is round or green? So I'm going to do probability of round or green. So what probability are we going to start with here? Probability of round. What is the probability of drawing a round token from this dish?
Five.
If you count all the round figures, there are 5. How many total tokens in this dish?
9.
There are 9 total, yes? So, probability of a round token is 5/9. Or, so since it's or, we're going to add. Now we're going to find probability of green. How many green tokens do we have?
3.
3?
3.
I would not recommend reducing. Because I need common denominators to add.
Yeah.
So there's 3 of them not filled in, so 3 green out of 9. Now, don't finish yet. Are there any overlaps?
Yeah.
Yes. So this is not mutually exclusive. So what we need to do is we need to do one more step, because there were some tokens that got counted in the round category and then got counted a second time in the green category. And so what we're going to do is we're going to subtract off any tokens that are round and green. So how many tokens
2 9s.
were round and green? There are 2, yes? So now we're going to subtract off 2 9ths. So 5 9ths plus 3 9ths minus 2 9ths.
2/3. I agree.
Okay? I'm going to say 8 9ths minus 2 9ths is 6 9ths. But then 6 9ths does reduce to 2/3. You can make that a decimal if you had to, right? I ran out of room there, so I didn't make it a decimal, but we've done a lot of making them decimals, so hopefully that has sunk in. Now, you guys want the shortcut here? I mean, you need to be able to show your work and stuff, but basically, round or green, if you go through and count everything that is round or green, you're going to have 6 tokens out of 9. Okay? Now, we don't always have all the individual information to do that, which is why we have to understand how this works mathematically as well. Okay. Unless there's questions, I'm going to go to the next one. So what is the probability that the token is square or red? So what am I doing first? We're going to count the squares. So probability of a square, any color. What do we have in the way of squares? Three ninths? Or tells me I'm going to add. And now I want the probability of red. How many are red? 3 again, so 3 ninths. Are there any tokens that are square and red? That I counted in my square category and in my red category? Yeah. How many did I count both times? So we're going to subtract off any that were square and red. Which, what'd you guys say?
One.
Just one? So we're going to subtract off 1/9. 3/9 plus 3/9 minus 1/9. 6/9 minus 1/9, 5/9. And again, you might have to go decimals on these. I'm not saying you wouldn't, but we've done a lot with decimals, so. One more?
6.
Okay. What is the probability that a token is? Green or square? Well, I feel like we've done both of these before, haven't we? What's the probability of green?
3/9.
If I cheat off of myself, I had 3/9 up top, didn't I? Or says I'm going to add. What's the probability of drawing a square?
3/9.
Square, 3/9. Are there any pieces that are green and squares?
Yes.
Yes, so since there's pieces that are green and squares, we need to subtract the overlap. So we're going to subtract any that were green and square. Levi says 1. Is that right? Yeah, green and square, 1/9. 3/9 plus 3/9. 6/9 minus 1/9 is 5/9. Okay, guys. Your homework is lesson 11.3 in Math Excel. Okay. Crazy thing, you actually have 6 minutes. You could work on it a little bit. But make sure you guys have it done for tomorrow.
Cut them off real quick. Sorry.